For this problem, what we want to do is we want to find the volume of the solid obtained by rotating the region bounded by y is equal to 4 minus x squared, y is equal to 0, about the x-axis. This is what we call the disk method because, well, from the intro, we are using this to estimate the area, not the area, the volume. First thing first, for these kind of problem, what you want to do is to be able to draw the graph and see what is the region that you're working with. So this graph is going to be a parabola that's going to be open down and shifted up by 4. And due to the fact that we have a boundary of y is equal to 0, nothing go past the x-axis. And that's the area that we're working with. Rotate this about the x-axis. Next thing we want to do, figure out where is the starting and stopping point. Since we are rotating around the x-axis, our limit of integration will actually take place from -1, or rather from whatever this lower value is to whatever this upper value might be. And if you do work out 0 is equal to 4 minus 4x squared, you are going to get that x is equal to plus or minus 1. And then try to draw your partial disk. The disk is going to be right there, perpendicular to wherever you are integrating. You are integrating with respect to x, the disk is going to be a vertical line. You are integrating with respect to y, the disk is going to be a horizontal line. Then next step, find the area of the disk with respect to x. Well, this disk have a radius that's going to be given by, so the disk intersect the graph right there at that point. From the line of from the axis of rotation to that point is precisely y is equal to 4 minus x squared. Otherwise, we can call that as r, the radius of our disk. Meaning, the area of the disk at any given x value is going to be given by pi r squared. And r is 4 minus 4x squared. 2, you want to set up your integration. The integration is going to be from your lower limit, which is going to be -1, to 1 of the area with respect to x. The x is changing. We are moving the x, and we are seeing how the area of this disk change along with it. -1 to 1 pi 4 minus 4x squared dx. Let me just bring out the pi to the outside. It's a constant. We don't have to worry about that. Multiply out everything on the inside. So that's going to be 16 minus 2ab. So 2 times 16 is going to be 32 x squared plus 16x to the 4th dx. We integrate everything. So the first term is going to be 16x minus 32 divided by 3 x cubed plus 16 over 5 x to the 5th. And we are evaluating this from -1 to 1. So then we can just plug everything in. Minus 32 over 3 times 1 plus 16 over 5 times 1 to the 5th, technically to the 3rd and to the 5th, minus what happened when you plug in negative 32 over 3 -1 to the 3rd plus 16 over 5 -1 to the 5th. And then now it's really is a calculator problem. So you are going to get 32 minus 2 times 32 over 3 plus 2 times 16 over 5, and we work off that out, and all of that is going to give us 256 pi over 15. So we want to find the volume of the solid obtained by rotating this region. So the x-axis is going to give us our limit, it's going to give us our variable of integration, meaning we are running from -1 to 1 when we integrate. And the only thing left to do is represent the radius of the disk with respect to your variable of integration. Now, let's take this exact same problem and let's try to do the opposite. Let's try to integrate it about the y-axis and let's see what happens. 4 minus 4x squared y is equal to 0 about y-axis. And let's see what changed. Again, we'll draw. Now, note that if we actually take this region and rotate it about the y-axis, we are actually doubling up on the volume because the left side will, the right side will cover the left side and the left side will cover the right side. So they will be covered twice. We will actually double up on the volume. Meaning that if we actually want to find the exact volume, due to the symmetry of the graph or the symmetry of the function, all we really care about is just one side of the function. We don't care about both sides. Then we can guarantee that there is no doubling up on the volume. So keep in mind, if you take this and you rotate it and try to find the volume, you are going to double up on the volume to make one full rotation. So there's a lot of ways to go about this, but I think the easiest way is to just cut it in half and just deal with 1/2 of that thing. So now, because we are rotating about the y-axis, we are actually moving upward, meaning here's our lower limit of integration and here is our upper limit of integration, meaning we are integrating with respect to y. What that means is that our disk is now horizontal. Because we are moving up, our disk is now horizontal. So the disk that you want to draw is going to be perpendicular to the direction that you are integrating in. So if we want to find the area of this disk, well, the area with respect to y is going to be pi times the radius. Now here the radius is a little bit difficult because here you are asking, at this point, given any y, at this point you are not trying to find y, you are integrating with respect to y, you are moving upward. What you are trying to find is x. You are trying to find the radius of this disk, so you are trying to find x. So given a y, what is x? What that means is that we have to solve for this function in terms of x. What that means is that y minus 4 is equal to minus 4x squared minus 4, x squared is equal to 1 minus y over 4. And then x is equal to plus or minus the square root of 1 minus y over 4. So then you have to, well, because we are dealing in the first quadrant, we are going to actually have to take the positive, we are going to have to take the positive x value. So our radius, our x, This is the radius because that's how far this is away from the line of rotation. Pi square root of 1 minus y over 4 squared, which is really just pi 1 minus y over 4. And now we just set up the integral and integrate, which is a lot easier than the other one because we don't have anything, we only have one variable. Well, we only have one term with a variable. So we are integrating with respect to y, so from 0 to 4, the area with respect to y, which is the integral of 0 to 4 of pi 1 minus y over 4 dy, which is going to be equal, sorry about that, let me write it over here, 1 minus y over 4 dy, part of pi, integral from 0 to 4 of 1 minus y over 4 dy, pi, integral of 1 with respect to y, integral of y square over 8, and then evaluate from 0 to 4. 0 is not going to give you anything, so it's just going to be pi 4 minus 16 over 8, which is just going to be divided by 8, so 2, 4 minus 2, so 2 pi. Right. So for this problem, I really do just want you to note what's the difference between integrating with respect to y and is integrating with respect to x. You really do have to draw your graph, and you have to draw your, the disk as well.